Hello everyone. We are students from Don Bosco Institute of Technology and we are from the Department of Information Technology. My team members are Malvika Shetty, Fiona Coutinho, and I am Kunal Pingale. The guide for our project is Professor Tayyabali. Our title for the project is Decision Support System for Groundwater Governance. We are from the batch of 2022 and this is our BE final year project. The idea for this project was seeded into our minds by our professor and our guide, Professor Tayyabali. And when we researched about this project, we realized that our thoughts also align with the necessity of this project. So we decided to pursue it. Okay. So firstly, I'll be explaining the current scenario, why we thought that this project is very relevant to the current situation. What we see is that 800 or around 800 villages are affected this year due to lack of groundwater or over exploitation of groundwater. So what is happening is that in Maharashtra, the major occupation is agriculture. When agriculture comes into picture, there is a lot of irrigation requirement. And to meet this irrigation requirement, farmers dig wells. Now, what is happening is that there is no supervision to the digging of wells. So one person is digging multiple wells and exploiting the rain, exploiting the water tables. So that which is leading to a shortage of groundwater in our state. We have adopted this system for our state, but it is relevant in many other states as well. So this is the problem statement that we have adopted. That since a long time there has been unauthorized or unsupervised exploitation of groundwater, due to which one farmer ends up with a dry well and another farmer has 4 to 5 wells and is using a lot of groundwater. So this is to bring a solution to this. We have come up with an idea. So yeah, so this is the summary of our problem statement. Like I have said that there has been unsupervised and unplanned water consumption leading to water scarcity. So there is a strong need for a system which is felt for all citizens so that they can know the groundwater situation in their area and efficiently use groundwater according to the requirement. So that is the need for our proposed system. That is the unplanned use. Also, we have come to the conclusion that people need to be made aware about the groundwater situation. When a person thinks about digging a well, he needs to know what his groundwater situation in his area is and what the scarcity or the other things that he needs to keep in mind before digging a well or exploiting groundwater. So yeah, so that is it. When it comes to, firstly, I'll be explaining what exactly we mean by wells and groundwater. So like you can see in the picture, there is surface water. And then when on the land area, the water that seeps into the surface is stored in a water table, which is there under the ground. Now, when a farmer digs a well, he digs it until the water table and he starts using that water. Now, for a region, the water table is constant. So even if in my land I am digging a well, I am actually using a water table which is common for the entire village or taluka. So that way, even if I am using water, it does not mean that I am using my water. I am using a common water table. So there needs to be a common system for all farmers in that region to use the groundwater efficiently. So that is this figure. The scope of our project. Firstly, it is to design a decision support system on groundwater of a particular area. The area that we will be focusing on is Osmanabad district because we have some data available for it. And in our research papers, we have seen that Osmanabad district has a little groundwater problems. This system will provide a platform for people to feed their data as well and view the analysis of the water availability and usage in their region. The analysis will be through graphs, maps, and charts, and it will be displayed on a web app. And a mobile app dashboard is also made. We will be focusing on aquifers, wells, borewells, rainfall, recharge structures, and irrigation, and the usage in domestic and commercial ways. The prediction of most viable solutions will also be provided, along with a few other prediction techniques that we have implemented. Okay, so before we started this project, we wanted to do a literature survey of what the pre-existing solutions or the pre-existing researches have. So the Groundwater Surveys and Development Agency, the GSDA, takes care of the groundwater surveys and other things that come into picture when it comes to groundwater. So there is a detailed information of the Maharashtra talukas there, but it is in the form of a PDF, and that data is very outdated. So what happens is that data is neither dynamic nor is it understandable for a normal person. For a normal person to understand that data, he will have to go through a lot of research and he will have to learn a lot of things. What we wanted to come up with, the gap that we identified is that the data is outdated and very less user friendly. Similarly, the Central Groundwater Board did the same thing, but there is no analysis or prediction. So it is just raw data that cannot be analyzed or interpreted. The Andhra Pradesh government has come up with a good solution, and they have come up with a website. But somewhere we also found that it does not have individual data, and it is a little confusing because it is a common dashboard. What we thought, if there is a different dashboard for a layman which is specific to individual person, then it would be better. Similarly, other literature surveys that we did, we found those gaps and we decided to solve them. So firstly, I'll be explaining the web app, our flowchart of the web app. So there will be a home page in which there will be a user registration and a manager login. Now, what we have come up with a solution is that there will be people of the village, or there will be a NGO that will adopt this project, and then we'll try to implement it. When it comes to NGOs, they will have some users. They will keep adding data to the website, and then that website will display the analysis based on the available data. Now, what could happen is that when a user adds data, he may add some inappropriate data, he may add something that is not correct, and that may hinder our analysis. So what we will be doing is, when a user uploads some data, it will have to first be verified by the manager and given a verification tag, after which the data will reach the dashboard. So like you can see that there is an app and web dashboard. Volunteers will add data, and that added data will be verified by the manager. So similarly, that manager and based on the verified data, there will be graphs and charts that will be created, and on that basis, a village or a region can take decisions. Okay, system modules. So these will be the three system modules that we'll have. First is the data collection module. Other is analysis on web app, and on the basis of our analysis, there will be some solutions that will be there. Firstly, on ground data, there will be locals or volunteers. So the local people can add data, or even volunteers who could be working for this project. Similarly, there will be analysis of on the dashboard, groundwater recharge, and in that analysis, we will be considering groundwater recharge, groundwater usage, and borewells, recharge structures that are available in the region. And on that basis, we will be providing solutions. So solutions to increase the groundwater availability, increase the borewells life, give them crop suggestions as per requirement, and the recharge that they need to, groundwater recharge that they need to do. Okay, so this is our tech stack for the project. We used HTML, CSS, JavaScript. We used the Django framework, GeoDjango for the maps implementation, OpenStreet mapping for the maps, and Leaflet for the maps implementation. The database was created in PostgreSQL. The server was AWS and GeoServer, and the software that we used was QGIS for the geospatial information. In machine learning, we have put in three machine learning models. First one is the linear regression, through which we'll be predicting the water recharged based on the rainfall and the individual water usage that could be suggested by the model, so that to keep a sustainable water life in the region. The other one that we've implemented is k-means clustering. Based on the depth and location, the wells will be clustered in of a region, and based on their average depth, we can be able to predict the water life in that region for the wells. Similarly, linear regression to predict the prediction of water life. Now we'll be doing the demonstration.
Thank you, Kunal. This is our landing page. As soon as you come on the website, you will be interrupted by a pop-up. This pop-up tells you to select a location. Here I've already selected Osmanabad district and selected all talukas within the district. Click on Save Changes. And on doing that, you will be on the home page. So our home page explains what this website or web app is all about. It is a portal for groundwater supervision and analysis of data. It, as Kunal has already explained, we'll be showing graphs, tables, and all the data in such a format that will be easily understood by laymen, since this is for the farmers and for the people who work on the ground. We have features such as interactive dashboard, visual view through maps. You can add your own data and view them on charts. You can verify your data. Your data will be verified by a manager. It will be user friendly, and we'll also be showing predictions using our ML models. And to save time, we have already kept all the tabs open. So moving on, we have two dashboards. One is for the farmer and the other one is for the government officials. Since we don't want the farmers and the local people to stress out over all the jargons of groundwater calculation, so we have a separate simple UI for them. Here it is, which is further divided into wells and borewells, rainfall, groundwater level, water usage, recharge structure, and land use. Right now, what you're seeing is Osmanabad wells and borewells analysis. Here you can see we have the total number of active wells, active borewells, then average depth of the wells and average depth of borewells. On the left, you can see the latest updates. This will be updated by the manager from time to time. Then we have under it, we have the pre-monsoon months, monsoon months, and the post-monsoon months. The monsoon months differ from region to region, and for Maharashtra, these are the months. Then we have a pie chart, donut chart, which represents the number of wells, and similarly for the bore wells. And then we have a table under it to represent it and show the fluctuations, like how much it has increased or decreased over the last year. Under it, we have the well groundwater level. Here on the left, we have a graph which shows the groundwater level versus the year. So it's 2020 and 2021 data is already available. And for groundwater level, we calculated using MBGL, that is meters below ground level. So if we see the table, in pre-monsoon, it is way below the ground level. So hence the number is high, it's way, the number of, like it's 60 meters. But during monsoon, the water level rises. Hence, it is not that lower than the surface area. So that's the reason it's only 30 MBGL. And similarly for the post groundwater level. And the same data has been represented in the graph format on the right. Moving down, we have a similar groundwater level data for borewell as well. Next, for rainfall, we have we've again used the same format: average rainfall, previous year average rainfall, average depth of wells, and we have average depth of borewells have shown. Again, here we have latest updates for rainfall related news. Then here you can see in between rainfall versus domestic groundwater usage. So here, depending on the amount of rainfall, we have predicted this much is the amount of water used for domestic purposes every year. So based on our analysis, this is like for if assuming a 600 mm rainfall, the amount of water used in post-monsoon groundwater on post-monsoon period would be around 45 liters per gallon. And the measurement used to calculate this water is LPCD, that is liters per capita per day. On the extreme right, we have a graph which shows rainfall versus year, according to since 2016, how the rainfall has varied until 2021. Moving on, we have the government official dashboard. Here, if you see, the terms are more we have more professional terms. Here, the government officials can take data for their research purposes and to further their experiments and research on groundwater development. Here you can see it's here the graph groundwater level versus year. So you can compare the groundwater level for Osmanabad district in the year 2021 and in the year 2022. You can see groundwater recharge was by rainfall versus the amount of rainfall in that region. Below, we have taken other individual elements such as water usage, water quality, the charge structure, crops, population. Moving on to maps. Now, maps has been the highlight for our project. Since they are very user-friendly, it's easy to understand a region using maps. Here right now, what we can see are the active wells in the region. If I remove and click on inactive wells, the green marker shows the inactive wells in the region. And if I click on this, so we have the red ones are the active borewells in the region. If I hover over it, you get to know the borewell ID, if it's a private well or a public borewell, the depth of the borewell. And if you click on learn more, you're taken back to the page where you can see this data, the complete dashboard. We also have an analyze option on the extreme right. You click on it, you'll get to see the summary of the wells and borewells of that region. What is their average depth and how many of them are there in a pie chart. On the left, bottom left, we have the index or the legend, as you might call, some might call it. And here on clicking on depth, we have a map which shows, I just remove the markers. Yeah. Here's a map which shows the depth of wells, borewells in that region. So according to the color, if you see, if it's light, it is a shallow well, that is 180 to 300 feet. The darkest one goes from 400 to 600 feet. So using these maps as well, we can analyze the region better. Moving on to the analysis page. Here we have used our ML prediction model, which we'll be showing. Here on our analysis page, we have used linear regression model to predict the amount of water used per capita for domestic usage. So assuming the rainfall is 500 mm, we click on predict and we get to see that it's 36 liters per capita per day has been used, can be used for this much amount of rainfall. So assuming I'll take one more example to be more clear. If the amount of rainfall is 1100 mm, so I can use 72 LPCD of amount of water. So the other model, which will predict the month in which the wells or the borewells will get dry, is still work in progress. Yeah. And since this whole portal is for the people, local people, we have made sure that the website is also in the local language, that is Marathi. Here you can see the home page is in Marathi language. Okay. Now moving on, as I mentioned at the start, we have a manager as well and a user as well. So first we're going to log in as a user and see. We're going to first log in as a user and add our well and see how the data is shown on the map. Selecting my location. Moving on, add data. Okay, here there is already one well added. And I'm gonna add 4, name, adding it and Kunal's name. When was it dug? Assuming it was dug in 2011. The depth is 40 meters. Let's say the location. You can see the lat and long has been automatically added. Next step, the village, Lechi, Osmanabad, check Osmanabad and click on add. Here we see your details have been saved successfully. Okay, now we will be going to the manager login and first we will log out. We'll be going to the manager login and see approving the well, and only then will it show verified. for the user. Login as manager. Here in manager, we have 4 options. That is the dashboard view, the add and view info, approval view, approval page, and all users and volunteers page. So right now we have to approve the well, hence we'll be going to approval page. Okay, if you see the pending approvals, no pending new users, clicking on well approvals. Once I added right now was user ID Kunal, clicking on OK. Okay. And there we go. We have 3 approved wells. If I click on it again, we only have 1 well remaining. To see how many users are there, we go on all users and volunteers. Yep. Here we can see there are 4 users and 2 of them have been selected as volunteers. You can see. If I want to remove one, I'll just click on them and go on OK. It's loading. And there you go. You have only 1 volunteer right now. If I want this into an Excel sheet, I can just click on this Excel button and it has got exported. Click on it. There you go. You get it in the Excel format as well. Okay, back to add and view info page. Now a manager will have to add information like the rainfall of that area, the public wells and borewells of that area. If the manager has to register new districts or talukas, so for that there is option. Like right now there are 3 districts under this web portal. If I have to add 1 more, I can add it from here. And similarly other things, public wells, public borewells, and the dashboard will show all the overall information of the number of talukas, villages, which are under the manager's jurisdiction. Well, the district assigned is Osmanabad for this manager. Total number of registered users are 4. And you can see the taluka and the villages under it are mentioned here. Here you can also see the taluka details, like the population, the average depth, and water recharged, etc. Well, that was all about our web portal.
Okay, so thank you, Malvika, for the demonstration. Now that we're done with the demonstration, we'll be moving on.
Okay, so this is the mobile view of our app because we want our farmers to be able to use them on the go as well. So we have made our app in mobile friendly too. So this is how it will be looking on the mobile. That is it about our project. Now this is similarly the mobile view. The future scope. So now we have brought this project to this extent, but what remains or could be added to this project as a feature is firstly that we could make an Android app for the addition of data viewing dashboards. Like there could be an Android app which could come in handy. Similarly, we could add more districts and talukas to make the project more versatile, or maybe the project could cover up more regions. Also, similarly, it could cover up many other factors as well. Like right now, we are working on groundwater only. Similarly, they could work on agriculture, soil exploitation. There could be other data. We could add more machine learning models with the added data. So right now, because of the COVID situation, we were not able to go gather data physically. So somewhere, if that is possible, we could collect more data and make better, efficient machine learning models. And through that, we could come up with prediction accuracy as well. These are the references that we took in coming up with this project and developing our solution. And yes, so thus a system for assisting individuals in groundwater related decisions is proposed. The project is focused right now on Osmanabad district, but the scope could very well be expanded. A dynamic web application will address issues like changes in data or incorrect data, and also it could always be correct data and relevant data. Like we have seen in our government websites, there are PDFs which are age old, 10-year-old. So this could bring in a factor of recent data or relevant data, and dashboards that are created on that data. So yeah, so that is it. Thank you. We would firstly like to thank our project guide for giving us the required support, and also our college for giving us this opportunity to pursue this project and give us all the materials and guidance that was needed while developing it. And I would also like to thank my team members for always cooperating and helping me come up with this solution.